Uh, Hello, everybody. Can you show my screen?
Yes, we can
Yeah,
see.
yeah. Hello, let's start. I'm Bomseok Kim. I work working for VUA, and I'm in charge of planning safety software. My presentation title is STPA application in Korea and ensuring safety of autonomous driving with STPA. This purpose is just let you know in terms of STPA application in Korea and STPA effective on autonomous system. Okay. Yeah. Today, my presentation content are as follow. And next is the first is why STPA and application in Korea. I think you don't know our company, so I just introduce our company in brief. Our head office is in Republic of Korea, South Korea, and one of our business is international standard consulting, like such as ISO 26262, IC 62304, SPICE, and so on, in terms of safety process consulting. Also, we provide a safety solution that support the STPA, FMEA, FTA method, called as Visual Flow SA. The last is we provide the training in terms of safety to our domestic customer, especially functional safety or cybersecurity. Let's start. What is the safety analysis? I think you most certainly know about that. Simple sentence is method to prevent accident in advance. Purpose is to identify design weakness, condition first, and causal analysis that may lead to violation of safety requirements. And there are many safety methods such as FMEA, FTA, HAZOP, ATA, and so on. But most of these methods are based on chain of event model. It means accident is caused by the consequence part of the component. I give you some example. In brake system, brake controller doesn't work and brake control valve cannot stop the vehicle and accident occur. To prevent this, the brake controller redundancy would be a solution against this accident. However, this method have a limitation. FMA FTA is suitable for analysis of component errors that make up the system, but not for interactions between complicated system or human operator, because it is based on machine and hardware of system characteristics. Also, this method created 6 or 7 decades ago. It makes harder for it to analyze new system or complex software or hardware system. Especially, it can do on system related on human operator. So many of researchers demand new safety method suitable for new system. As you can see, recent system accidents are pretty much occurred by unforeseen interactions. STP is system theoretic process analysis based on STEMP. STEP is system thinking theory, which means the system is not the simple sum of the parts that make up the system, but it's done by organic interaction of each part. But STEMP is just theory, not provides the method. So STPA is the method based on the STEMP. It was created by Nancy Levinson of MIT professor in 2012. A little over a decade later, many studies have been conducted and proven and verified as to be effective in many fields. It's a concept of STPA-based control loop, control the controlled process through the actuator and get the feedback through the sensor. With this concept, you can find each component single failure and interaction failure both. To also enable high complex system analysis and identify safety requirements and safety constraints in early stage of designing system. Also, you can do the STPSec, cybersecurity. In terms of STPSec, you can analyze your system safety and security perspective at the same time. Now, I'm going to take a look at STPA application in Korea. STPA handbook was already translated by TTA in 2018. Also, TTA released the risk management guide with STPA in 2019. And it has been downloaded over 5,000 more. And as I know, STPA is already applied in many industry fields in Japan. Especially in Korea, research has recently moved from the universities to the industry, and many of research progressing gradually. STPA can be applied in many fields, many industry, and I will show you the application in Korea. First industry is automotive. I ask your understanding before I show you, because the original research documents were quoted and written in Korean. So Korean is inevitable included, but it is simple example of a smart key vehicle. The control structure has been configured as a modules linked to the smart key. Smart key has a connection with 5 modules of vehicle system. Especially, this research describe the STPA advantage of the finding and preventing faults in system designing process. It was done the self-driving cars. Furthermore, the error found early were applied to the simulation. The simulation environment used the ASM model of DSPICE in German. It's configured to inject the error into the input and output stage of a model using control desk tool. By applied simulation, they were able to improve reliability of the STPA analysis. Also, we have started the co-work with Hyundai Motor in this year with STPA. We are also trying to do STPA analysis to match their new system and new environment. Next is railway industry. This research identified the possible hazard through the control flow between the ATS controller and signal and the train. Problems that may occur in train control software were analyzed by the STPA. Next is cybersecurity. STPSec enables analysis of both safety and security perspective in UAV system. In particular, STRIDE was applied as a threat method to create the scenarios, those scenarios for cybersecurity threat, and to summarize the requirements accordingly. These days, the needs and importance of cybersecurity are being emphasized. We are also interested in STPA and cybersecurity. However, STPA SEC also includes only qualitative analysis of a cyber threat. So we are considering ways to reflect the cybersecurity threat assessment in STPA to consider ISO 21434 and others. Next is nuclear energy application. This is multi-purpose research that reactor of domestic technology designed by and built by the Korean Atomic Energy Research Institute. It is characterized by the fact that it is a reactor that can conduct research and experiment at the same time. STPA was applied to the reactor for possible problem in interaction with the human operator. They explained the positive effects of research that can broaden perspective on problem by simply being able to identify problem between users and reactors. It's another researcher from Korea Atomic Energy Research Institute, hazard analysis about the NPP, nuclear power plant safety and INC system. This analysis also allows them to consider the human operator from analysis perspective, which allows to identify a slightly wider range of risk factors and further increase the stability. They also explain the strength of STPA analysis in very large system called MPP, which can be analyzed through the STPA. This is possible with the this is impossible with the FMEA or FTA method. The last STPA application is for software. This is an example of software safety analysis based on the model. It reflects the slight change in the control flow to consider the characteristics of the software. Most of all, the software interacts from the control perspective, which is useful for STPA analysis. So far, I have introduced the STPA research in our country. And now I'm going to analyze example of the autonomous driving according to STPA step. Basically, STPA has a 4-step. First is define purpose of the analysis, and second is model of control structure, and third is identify unsafe control action, and the last is identify loss scenario. This is first step, identify system losses and hazard. STPA recommends not to identify many losses and hazard. If you define many, it would be taking a lot of time or lots of time, and you would focus on specific issue, not entirely. Here is 4 losses and hazard of autonomous driving. The road car can be replaced as a vehicle and either have a connection between losses and system level hazard. It make you keep traceability on your system. Second is the model of control structure. In my opinion, This step is single most important step in STPA. This is very simple example of the autonomous driving, but you can start to analysis like this simple example. It is STPA strength. It is consisted of the from human controller and to the each physical system. In the beginning of system designing, you can start very simple control structure to get more deeply to level 2 or level 3 continuously. Third step is identify unsafe control action. As I mentioned, SPA assume the problem caused by control. SPA has a 4 type of control action. Usually, it can make the control action to unsafe. For example, usually number 2, not maintain a safety distance from the car in front of your car, but brake is not provided. This usually could be a problem on your system. Also, it is important to link this usually to identify hazard in advance. This usually can be connected to all hazard already you define or already identify. Like this, you can make the U-shape from all of the control action you already identify. The final step is identifying the loss scenarios. Loss scenario is usually based on U-shape. When you identify loss scenario, you have considered the control loop. It means the region which part usually occurs. It could be an autonomous system and system algorithm failure on their own. Also, it could be a brake control problem and braking system failure or sensor failure. Through this diverse perspective, you can identify loss scenarios. If you want to go more analysis more deeply, you can find the causal factor based on these loss scenarios. This progress is good for setting the functional safety requirement on your system. In advance, we can detect the many loss scenarios by using STPA theory. And then I'm gonna apply the FTA method on this system. FTA can identify the causal factor more specific and precision than STPA in a way. By the use of AND OR gate, you can derive the sensor failure more deeply. This slide shows the sensor failure in some example by using FTA result. After finding the causal factors, you can calculate each component failure rate already defined in variant standard such as SN 29500 or IS 62380 and so on. It gives you the availability to quantitative analysis and top event failure rate. It can also improve your accuracy of analysis. Also, COSET gives you the way that causal factors, which causal factor affect to the sensor most quickly. This is gives you the priority that which causal factor must be solved first. By combining STPA with FTA, problem at the system level can be identified first, and individual problem can be found through the FTA. By using this, I believe that the requirement of functional safety and safety analysis required by ISO 26262, such as can be solved. Although STPA has many advantages, FMA and FTA, other conventional methods are also used for the analysis for a long time. It is clear that there are advantages, especially when it comes to finding errors in components, such as calculating the failure rate. Yeah. So our company continues to study and develop how effectively integrate the STPA with existing or conventional safety analysis method. Also, it is our challenge to analyze the future system. Last conclusion, they're saying that pour new wine into new wine skin. It means new system need new safety analysis method if it is effective. And STPA shows the new solution compared to other conventional methods. However, if traditional or conventional method can be improved the STPA advantage or benefit, it would be a good choice to apply a part of conventional method as well. STPA can be used to analyze the beginning of stage of system development. It is believed that this can prevent a possible risk hazard with tight safety net. In the early of system of development, I hope this method I present will help you find a solution and take you one step further. Thank you very much.